Hello everyone, I am Dr. Ariel Ruiz-Garcia and I am a Senior AI Technology Engineer at SeaChange. Today I will be talking about self-supervised transformers for activity classification using ambient sensors. And before I begin, just as a disclaimer, this is part of a PhD project being done by one of the authors, Luke Hicks at Coventry University, and my contribution to this work was done before I joined SeaChange. So self-supervised learning is becoming a popular pre-training approach for deep neural models. This is mainly due to their outstanding performance with limited amounts of labeled data. Traditionally, in self-supervised models, we use contrastive loss and an encoder-decoder architecture. The encoder is normally the model that we want to fine-tune for classification in the end. So in a setup like this, you normally take two different views of the same input, and you can obtain them using some sort of augmentation. You pass those two representations of the same input through the model, and you try to minimize the distance between those two hidden representations of the same input. But at the same time, you try to maximize their distance to the negative samples, which essentially are views of different inputs in the training set. These models achieve state-of-the-art performance when fine-tuned for classification using a small amount of label data. However, one of the main constraints about self-supervised learning is that they require a lot of unlabeled data. So in this work, we are proposing to reformulate self-supervised learning as a regression and classification approach. Instead of using contrastive loss, we add a classification layer to the model, and we also add a full decoder with similar topology as the encoder, with the main difference being that instead of using any sort of downsampling layers like max pooling, we use upsampling layers like deconvolutional layers, so that we can map the hidden representation back to a full representation of the input. And as you can see in this diagram, we have a transformer encoder, but this can be applied to or adapted to any other architecture, such as convolutional neural networks. And just like normal self-supervised models, we also have two different views of the same input. The main difference is the classification head as well as the decoder model. So the idea behind this approach is to use this for activity recognition in smart environments, mainly for the elderly. And as you can see, this is an example layout of an apartment building fitted with many sensors that we use to do activity recognition. And the main goal is that we should be able to prevent any sort of accidents by knowing what's going on inside that building. So this is early work, but our initial results have shown that by using this approach as opposed to traditional self-supervised models, our model can reach convergence much faster when fine-tuning it for classification, and also works on a smaller amount of unlabeled data. And well, one of the main challenges in this approach that we have faced so far is knowing what augmentations to apply for the input, so that we can obtain two different views of the same input. So we are looking into that. Finally, our main goal here is to do activity recognition in smart environments.